Following on from differentiating trig functions, last lesson we're now going to look at integrating some basic trig functions, specifically functions involving sin x and cos x. There are also a number of standard integrals and derivatives that are given in the formula booklet, so we're going to have a look at how we can make use of that. First, I'd like you to have a look at the differentiation we did last lesson. We had a go at some of these. Have a look at them with a mind to the fact that integration is the reverse process of differentiation, to try and inform yourself about how we might be able to integrate functions involving sine and cos. Did you manage to work that one out? The integral of sine kx with respect to x is minus 1 over k cos kx plus c. The integral of cos kx with respect to x is 1 over k sine kx plus c. Well, if you think about differentiating, if we're differentiating sine of something, sine to cos. So it's not hard from that to see that cos would go to sine, and if we're multiplying by, when we're differentiating, we'll be dividing by that part of the compound angle when we integrate. It's the reverse process. Same logic is true here. Cos actually goes to minus sine, but minus cos goes to sine. So we can see here a very similar process. Here, sine differentiates to cos, cos differentiates to minus sine to minus cos, and minus cos to sine, and so on. So going clockwise, we're differentiating. Integrating is the opposite way. So you can see here that going anti-clockwise, sine goes to minus cos, cos goes to sine, and you can see those results up there. So to integrate sine 5x, well, sine goes to minus cos if we follow our circle anti-clockwise, and the 5 goes underneath, so doesn't it? So it becomes minus 1/5 cos, and the compound angle stays the same, 5x. There we are. Don't forget the plus c. We have the constant of integration, because we don't know what constants have disappeared when we've differentiated. Let's try another one. 7 sine 5x. Well, again, sine goes to minus cos, the angle stays the same, and the 5 goes underneath. So we get minus 7 over 5 cos 5x plus c. There are some pretty complicated looking trig functions that you're asked to integrate in Core 3, but they're not as bad as they look because they're in the formula booklet. It's important to note though that there are two places to look. The obvious one, we look at integrals and we get the results here, but we can also use the differentiation section the other way round. So obviously, being a reverse process, we can integrate by using the derivatives here in reverse. What about cot x then? Using the formula booklet, and then mod of sine x plus c. What about that nasty looking integral? There we are. That just integrates to a half cosec 2x plus c. Notice the angles staying the same, and here we're dividing by, hence the half here. minus 3 cot 3x goes to minus a third ln of mod of sine 3x plus c. At this stage we can't integrate sine squared x and cos squared x. In order to do that we need to use the double angle formula that we learn in Core 4. Okay, well you're now equipped to deal with these sort of questions, so have a quick go at this matchup. If you're successful with it, then I think you're about ready for the lesson on integrating trig functions. Pause the presentation and have a go. And that's what you should have got.